Hi everyone, we're going to find two explicit functions by solving for y in terms of x. We're going to graph, and then we're going to differentiate implicitly and explicitly, and they should match up. So the first thing I'm going to do, I notice that this is a ellipse. I can write this as x squared over 16 plus y squared over 9 equals 1. I just divided everything by 144. But in solving for y in terms of x, we're merely going to write this as 16y squared equals 144 minus 9x squared. Then we're going to multiply both sides by 1 over 16. In this case, I can factor out 9. So this would be 9 over 16 times 16 minus x squared. And then I take the square root of both sides. You take the square root of, it's going to be plus and minus. Square root of 9 over 16 is 3/4. And then I'll have the square root of 16 minus x squared. So that's your two functions. I went ahead and graphed this. Basically, your center is 0, 0. Your A is plus and minus 4. Your B is plus or minus 3. So the 4 is under the x. So I went over 4 to the right and to the left. And for the y, I went up 3 and down 3. And as far as your graphing part, the first equation would be 3/4 times the square root of 16 minus x squared. And that would be this top portion here. Whoops. And the bottom, the second function would be negative 3/4 times the square root of 16 minus x squared. So that would be this one down here. Alright, now we have to differentiate explicitly. So I have, again, let's go back to the white paper. We have y equals plus or minus 3/4, and I'm going to go ahead and write this as 16 minus x squared to the 1/2. And I'm going to differentiate with y with respect to x. So I'm going to go ahead and use my chain rule and multiply 3/4 times 1/2 times 16 minus x squared. This would be to the negative 1/2. And then you also have to differentiate the inner function, which is 2x. Now, cleaning this up, we're going to get plus or minus 3/8. This would be negative 2 times negative 2x. And then this would be the same, 16 minus x squared to the negative 1/2. So simplifying, since this is negative, I just merely switch the minus and the plus, and that's going to end up being 3/4. And what I can do, let me just change that. I'm going to put the minus at the top. The 4 at the bottom is going to be the positive. And then I'm going to have the square root of 16 minus x squared. Now, oh, this is negative 3x. I forgot my x. Alright, now I want to solve this because I have to do this implicitly. I know that y equals this. So what I'm going to do here is take a little thing. I'm going to multiply both sides of the equation here by 4/3. So 4/3 y equals the square root of 16 minus x squared. Alright? So when I do that, I'm going to get equals negative 3x over 4, and this whole thing equals 4/3 y. Now, cleaning this up, we're going to get negative 3x over 16 over 3y, and we can merely bring this 3 up here. So my final answer is going to be negative 9x over 16. The reason we did all this extra stuff is because we have to do this implicitly as well. So for implicitly, I'm going to take my equation and write it back to the original equation, which was 9x squared plus 16y squared equals 144. And then I'm going to differentiate this. So this one is merely 18x. Since we have a y here, this is going to be, do your inner function, or outer function, that's 32y to the first times the derivative of y equals 0. Now to solve for the derivative of y, I'm merely going to move I'm going to write 32 times y to the first. I should probably just get rid of that because they look the same. Alright, times the derivative of y equals negative 18x. And then I'm going to divide both sides by 32y. And I do not know why I write stuff down that I have no reason doing. So that's y prime. So we get y, the derivative of y equals negative 9x over 16y, which matches our explicit differentiation. And that's all. Thank you. Have a nice day. Bye-bye.